Welcome back again to Engineering Mechanics, dear viewers. I just tried to record this, but unfortunately I had not switched on the camera. Let us do it again. Let's it's now problem set 2.4, solution to 2.48. On the string ACEDB, A to C, from C to E, from E to D, from D to B, is one continuous string. Equal weights Q, are symmetrically placed with respect to the vertical. Its weight is Q, means its weight mg vertically downward, its weight mg vertically downward, its weight mg vertically downward, mg mass into g. They are equal mass, therefore equal weight, and the mg is represented as q, right? To the vertical through the midpoint E. E is the midpoint of this whole string. Determine the value of the angles beta if the other angles are as shown in the figure. Now, look, from E to D is equal to from E to C, and this is the horizontal line. So this angle is given as beta, this angle is given as beta. Now, we have to find out that. Now, let in the part AC, let the axial force be the tension force. It will be the tension force acting from the point C, away from the point C to this side. If you consider point A, it is acting to this side, S1. Similarly, in the part CE, the axial force is S2, acting to this side for point T, acting to this side for point C. Similarly, the axial force, the tension force S3, acting from point E towards this side, from point D towards this side. Similarly, let it be S4. In the part BD, the axial force, the tension force S4, acting to this side for this point. Now, let us draw the free body diagram at point E. At point E, if you draw this horizontal line, this horizontal line is same thing as this x-axis, and this vertical line is same thing as a y-axis. Now the question is, in the free body diagram, how this angle is beta and this angle is beta. Let me explain here in the original diagram. This dotted line and this horizontal line, red line, they are parallel. This is the transversal. This angle is given beta, so this angle will also be beta because alternate angle. Similarly, CE part of the string is also a transversal. So this angle will be equal to this angle because alternate angle. So beta, that is what I have shown here and here. So, and S3, this is your S3, S2, your S2, right? So you already know how to have a projection of a vector quantity along x-axis and y-axis. If you look at this S3 making angle beta, if you drop a perpendicular from here and take cos theta and cross multiply, this part from here to here will be S3 cos beta, that is the x component of the tension force S3. From here, if you drop a perpendicular on a y-axis, from here to here will be the projection of the quantity S3 along a y-axis, and that will be S3 sin beta. Similarly, this is the tension force S2. I have drawn a perpendicular here, I have drawn a perpendicular here. Therefore, this part from point E to this point will be your S2 cos beta, and from here to here, this one, watch it carefully, from here will be S2 sin beta. Now, let us apply the conditions of equilibrium. Let us take first x-axis. Sigma x is equal to 0, means sum of the forces along x-axis is 0. So, this is your S2 cos beta and this is your S3 cos beta. They are already opposite. So, if they are equal, they will cancel each other. So, I have made them equal. Cos beta cancel. So, S2 is equal to your S3. Now then again apply the sigma y is equal to 0, means vector sum of the forces along the y-axis is equal to 0. Now this S3 sine beta plus S2 sine beta, they are in the same direction, so they are added, and Q is opposite to that. So S2 sine beta plus S3 sine beta is equal to Q. Now since S2 is equal to S3, which I just explained here, for S3 I put S2, so this becomes 2 S2 sine beta is equal to Q, so S2 is equal to Q over 2 times sine beta. And since S2 is equal to S3, so for S2 I write S3, so this also Q over 2 times sine beta, since S2 is equal to S3. So I hope by now you are familiar with projections, how to solve a system of forces in equilibrium, concurrent forces, by using method of projections. In problem set 2.3 we discussed about Lami's theorem. Now I hope I have made a good effort in explaining all my videos so far. If you feel like, give back your feedback, feed in a comment section. Thank you for watching, viewers from Bangladesh. Now then let us go back to the point C. This point, there are concurrent forces in the same plane. S2 to this side, S1 to this side, and the weight Q is to this side. Let me draw the free body diagram at point of concurrence C. So at the point of concurrence C, the free body diagram. Now this is your S2, this is your S1, this one is Q. Now the question is how this angle is 60 degree. This angle is 60 degree, right? Now this dotted line, if I extend, is the same this dotted line, that is x-axis. And this line is your y-axis that I have shown here. So this is 60, so this angle is alternate to this 60, so this is also 60 degree. And this is beta is known. Now apply sigma x is equal to 0. Means sum of the forces along x-axis is 0. This Q is completely along y-axis, so this does not have a x component. From this point, if you drop a perpendicular, then this one will be the x component of S2, then this will be equal to your S2 cos beta. If you drop a perpendicular here, from this point to this point, will be your S2 sin beta. Similarly, drop a perpendicular here, drop a perpendicular here. This one will be equal to your S1 sin 60, and this one will be equal to S1 cos of 60 degree. Now sigma x is equal to 0. We have two forces, S1 cos 60, S2 cos beta, opposite to each other along x-axis at the point C. So if they are equal in magnitude, they will cancel. So now so S2 was this much. Here cos beta remains same. Now cos beta over sin beta is cotangent beta, and 1 by 2 Q. So S1 cos 60 is equal to this much. So S1 remains as S1, cos 60 is half, 1 by 2 Q times cot beta, Q times cot beta. So half is multiplied on this side, half is multiplied, so they are cancelled. So I am left with S1 is equal to Q times cot beta. Now let us apply sigma y is equal to 0, that is Q plus S2 sin beta in the same direction, so say they will be added. S1 sin 60 is opposite to that. So S1 sin 60 is equal to S2 sin beta plus Q. Now put the value of S1 and S2. So S1 is equal to Q times cot beta, which I just explained. Then sin 60 is root 3 by 2. S2 Q times 2 sin beta. Then this sin beta is this plus Q. Sorry, this 2 is not cancelled. This 2 is there, this 2 is there. This cannot be cancelled because there is an addition term here. So sine beta cancels. So it is q over 2 plus q. So that becomes 3q over 2 is equal to this. Now the 2 can be cancelled, no? So now the q is cancelled because both are multiplied on either side. So I'm left with cot beta root 3 over 2 is equal to 3 by 2. So cot beta, this goes to the other side, becomes 3 over root 3, that is root 3. So beta is equal to 30 degree, right? So thank you for watching. If you are happy and contented with the contents, you can subscribe and give a feedback if you like, and pass on to your friends